Alright, so this is section 3 of chapter 2, and this is all about acceleration. And so we're going to talk about what is acceleration. And so acceleration is just the rate and change in velocity. So meaning that if velocity changes over any period of time, something is accelerating. So the key is that velocity is changing over some period of time. So remember that velocity can be a change in how fast something is moving or in some kind of direction. So just to clarify, so something is accelerating if it's speeding up, maybe speeding up, okay, because it's changing velocity. Obviously its speed's changing and velocity is speed and direction. It's slowing down, again, changing velocity, and again it's accelerating because it's changing direction. So keep in mind that even though something may go at a constant speed, like 10 meters per second, that if it changes direction, it still would be having a change in velocity because of the fact that it's changing direction. This picture down here would be a good example of that. It's going around in a circle. Even if it was going around in that circle in a constant speed, it would have a change in velocity because of the fact that it's changing direction. There are different types of acceleration. One specific type of acceleration is called centripetal acceleration. Centripetal acceleration is where you just have acceleration towards the center of a curved or circular path. So if something is moving in a circular path, the acceleration, as you notice in this picture, is all going towards the center, and that's centripetal acceleration. We have an equation for calculating calculating acceleration. So acceleration is taking the change in velocity and dividing it by the time. Now we represent that by this equation right here. A equals Vf minus Vi over t. Now what are some of those little symbols mean? Okay, let's start out with Vf. Vf just represents velocity final. Okay. Vi represents velocity initial. So basically, if we talk about what these two things are, this is the velocity when something stops or ends. This is when it starts. Or I guess you could say the beginning. So you always take the stopping value minus the starting value. So notice, if you kind of think about it a little bit, you could get a negative acceleration. And that's okay. That means that the object that you're talking about is actually slowing down. Now, the only other thing we didn't talk about is what is this t value. T just stands obviously for time. And we measure that in seconds. Both of our velocities, which we've talked about velocity before, is in meters per second. Our units for acceleration we would write as meters per second squared. Okay. So there's your whole equation. There's what everything means. So of course it probably would be a good idea to do some practice problems. Alright, so I want to start by writing down our equation. So we have A equals Vf minus Vi over t. So I need A, Vf, Vi, and t. I need those things. So the problem says that a jet airliner starts at rest at the end of a runway and reaches a velocity of 80 meters per second east in 20 seconds. Okay, so we pick out some numbers here. 80 meters per second. Now these these problems you're going to have to read the little like paragraph a little bit more. Okay? Because we're like, okay, well what does the 80 mean? Well, first of all it says starts at rest. Okay, well if I start at rest, what's my velocity? I start at rest meaning I'm not moving, so that means that my velocity I start with is 0. Well, start velocity is initial velocity, so initial velocity is 0 meters per second. Well, that means then if they give me a second velocity, which in this case they do, 80 meters per second, that's going to be my final velocity. Then they continue on to tell me that I have 20 seconds. Seconds is a time, so that must be this, t. Leaving me the only variable that I do not know, a value of a. So that means that a is equal to my 80 minus 0 over 20. Or just 80 divided by 20. Or mathematically, right, it's just 8 divided by 2, which is 4. We solved for a, so that means you're going to have a label of meters per second squared. Okay? Alright, let's try another one. Alright, so A equals VF minus VI over T. Okay, and so A, VF, VI, and T. Alright, so let's see. The skateboarder is moving in a straight line with a velocity of 3 meters per second and north. I think that's just supposed to say, sorry, my English is not very good there. I think we need to take out that north. 3 meters per second north. I think actually the and was supposed to come there, wasn't it? And comes to a stop. What is the skateboarder's acceleration? Alright, so the key is that they're moving, right? And then they come to a stop. So they're moving initially at 3 meters per second. Then they come to a stop. So since they started at 3 meters per second and then they came to a stop, my initial's 3 and my final's 0. Now, my time is the 2 seconds that they gave me. So 2, and then my acceleration I do not know. So A is equal to V final, which is 0, minus 3 over 2. So A is equal to negative 3 over 2. So A is equal to negative, and you're going to go ahead and divide that out. So 1 point, so that'll go in there, let's see, 2 will go in there one time with 1 left over, 1.5. And that's meters per second squared. Okay, so there you go. There's a couple of acceleration problems.